All right, so Chapter 11, Lesson 5 is appropriate measures. Okay? In the warm-up, it says the Green Committee had a recycling drive where they collected aluminum cans, plastic bottles, newspapers, and batteries. The weights collected on the first day are shown. So here we have cans are 12.2 pounds, plastic bottles 11 pounds, newspapers is 19.5 pounds, and batteries 13 pounds. Okay? So here we want to find the mean of the weight collected. So to find the mean, all we do is add them all together and divide by 4. Very good. So here is what you get when you do that. So here we've got 55.7 divided by 4, and we get 13.9. Number 2 says, now if the newspapers are not included, find the mean weight to the nearest hundredth. So here, we're just going to add the cans, the bottles, and the batteries, and what will we divide by? 3. Divide by 3. Very good. So here, when we do that, we get 36.2 divided by 3, which gives us 12.07 pounds. So number 3 says, how does the weight of the newspapers affect the mean? So here, it causes the mean to be about 2 pounds higher if it's included. So 2 pounds less if we take the mean out of there. All right, so now we're going to be using the mean, the median, and the mode. Okay? Using the mean, the median, and the mode. Now, we want to decide when each one of these measures is most appropriate. Okay? I want you to make sure you write these down. So the mean is most appropriate when the data have no extreme values. So if we don't have any outliers, then the mean is the way to go. Okay? If we don't have any numbers that are way higher or way lower, then that's the one we want to choose. Okay? The median, we would use the median if the data do have extreme values. Okay? If there are outliers, then we should use the median. And also, if there are no big gaps in the middle of the data. Okay? And then finally, we use the mode if the data have any repeated numbers. So sometimes one measure is more appropriate to use to summarize the data set than others. Okay? So for the first example, the table shows the number of medals won by the U.S. Which measure of center best represents the data? Then we want to find that measure of center. So if we want to look at this, okay, looking at each one of this data, okay, and we're looking at the number of medals. Do we have any extremes? Okay, no extremes. Do I have any repeats?
Yes. No.
No. Do I have any big gaps in the data?
No.
No. Okay. So, because we don't have any of that, if we are looking, there are no extreme values, we don't have any big gaps, and we don't have any repeated numbers, then the best measure would be the mean. Is everybody clear with that? So here, because of all that, we're going to find the mean. So to find the mean, we add them all up and then divide by 5. So we end up with 104 3/5. Example 2 says the table shows the water temperature over several days. Which measure of center best represents the data? Then find the measure. So here, okay, we've got 82, 82, 85, 82, 82, 78, and 81. So let's just go through our list again. Does the data have any extremes? No. Let's see. Are there any big gaps in the data? No, no. Does the data have any repeated numbers? Yes. The data has, what is 82 repeated 4 times, right? So, if we have repeated data, what are we going to use? The mode. Very good. So, the mode is the best measure, and the mode is 82. All right, so for the guide, this is the one I want you to write down, okay? It says, the prices of several DVDs are as follows. We want to know which measure center best represents the data, and then we want to justify our selection, and then find the measure. So, the first thing I did was I put the data in order from least to greatest. Even though you don't really have to. Even though you don't really have to, I did just so I could see the data better. Okay. So here is my data, and now we want to ask ourselves, are there any extremes in that data? No. Okay. Are there any big gaps in the data?
No.
No. Let's see. And does the data have any repeated numbers?
Yes.
Yes. So, because the data has repeated numbers, which one's repeated? 2195, 2195. Then, which measure would be best?
The mode.
The mode. Very good. So, since there aren't many, I'm going to say, just since there are repeated prices, the mode, $21.95, $21.95, is the measure center that best represents the data. So not only do you have to go through that checklist, right? You also have to write your conclusion sentence. All right, oops, Daisy, we forgot one. Yes, there's 3 of them in here. So it's $21.95, $21.95, and $21.95. So in my list, I should have had another $21.95 in there, so that just reinforces the fact that we have repeats, right? All right. All right, so outliers and appropriate measures. Make sure you write down your headings, outliers and appropriate measures. Now, sometimes data sets contain outliers. Outliers are deviations from the majority of the data set. Make sure you know that outliers are deviations from the majority of the data set. And of course, the outlier may affect the measures of center, just like we saw in our warm-up. Okay? All right. So for the next example, it says the table shows average lifespans of some animals. The first thing we want to do is identify the outlier in the data set. That's our step 1. Identify the outlier in the data set. That's step 1. Make sure you write that down. So, you guys know we have a process that we use and a formula that we use to determine outliers, right? When we look at the lower limit and the upper limit, right? But if you look at a set of data, you see this data here? And it's pretty obvious that which one is the outlier. Pretty obvious which one is the outlier. Yeah. Do I have to go through all of those formulas and calculations?
No.
No. So here we do have an outlier. That's going to be 200. Is everybody clear?
No.
All right. So compared to the other values, 200 years is extremely high, so it is an outlier. Okay? Step 2 is determine how the outlier affects the mean, the median, and the mode of the data. So this one is where you're going to have to do quite a bit of work. So make sure you write this down. Determine how the outlier affects the mean, the median, and the mode of the data. So what you're going to have to do here is you're going to have to find out what is the mean, median, and mode with the outlier, and what is the mean, median, and mode without the outlier. So you're going to have to find those measures of centers twice. Is everybody clear with that? All right. So here are the mean, median, modes already done for you in this example. So we have 62, 35, and 30 for the mean, median, and mode. And then without the outlier, we have 39, 32.5, and 30. So when we're comparing these, all right, first thing we want to look at is the mean, okay? The mean obviously changed a lot. Does everybody see that? So that tells me in this data set, the mean is not a good measure of center for this data. Is everybody clear with that? Then we're going to look at the median. So the median, 35 and 32.5. Not bad, right? Not bad. So here the median lifespan decreased from 35 to 32.5, so about 2.5 years. And then look at the mode. Did the mode change at all? No. No. The mode didn't change at all. So now, knowing that information, the next step is to decide which measure of center best describes data with and without the outlier. So here, the mean was affected the most with the outlier and without the outlier. The median lifespan changed very little without the outlier, so it best describes the data in both cases. The mode does not describe the data very well since there are only 2 repeated numbers. So for this example, it says the prices of some new athletic shoes are shown in the table. So here, once again, I like to put my data in order from least to greatest so I can observe the data easier. So first thing we want to do is identify if there's an outlier. So here, of course, there is an outlier at $78.95. Okay? Second thing we need to do is determine how the outlier affects the mean, median, and mode of the data with the outlier and without the outlier. So first we want to determine the mean with the outlier and the mean without the outlier. So when we add up all of this data, we get 366.7, and we're going to divide by 7. And when we do that, we get $52.33. That is with the outlier. So now we want to take that outlier out and then find the mean again. So when we take it out, we end up with $287.35. Dividing by 6 now, because we took the outlier out, there's only 6 numbers that we're going to calculate. So we end up with $47.89. So now we want to find the median with and without. So the median, here if I have 7 numbers, okay, my median number here would be 4850, right? So there, 4850. Okay? Now, erase this. Without, so that now we're going to take that $78.95 out of there to find the median. If we're finding the median without it, if I take this out, then I've got these 2 numbers that are in the middle, right? So I need to add those and divide by 2. Very good. So here, we have $47.50 plus $48.50, and we're going to divide that by 2. and we end up with $48. And then finally, we want to check out the mode. Are there any repeated values in there? No. So here, there's no mode with, and there's no mode without. So now the final step is to tell which measure of center best describes the data with and without the outlier. So here, the mean price was affected the most with the outlier, right? So there's the mean. It was affected the most with the outlier. So that tells me that the mean is not a good measure of center. Is everybody clear with that? Okay. The median price changed very little and, with and without the outlier. And of course, there's no mode. So which one is the best descriptor? The median.